Hello friends, welcome back to another video on this channel. In today's video, I will show you how I made my Arduino based RC drone. So basically what I have here is an Arduino Nano with an MPU 6050 gyroscope, both of which combine together to give me a drone ka Jugaadu flight controller. Right, so basically the thing is, the way this works is basically this will give us the orientation of the drone, and that is then taken by the microcontroller. And so basically the point of this whole setup is to make sure that the drone stays steady and like it should stay in this orientation, like it should not be tilted or anything, because if it tilts like this then it will start going that way, and that is exactly what we don't want. So we want the drone to be stable. So for that it takes the orientation from this. It will input it into a PID loop which will control all four motors and ensure that it stays exactly level. Now once we move our joystick on any of the sides, basically it'll take that input and it will scale it according to the gyroscope input. So basically if you move it slightly, then it'll keep it like that, and as you move it more it starts turning more. So and then it'll keep that angle locked. So the point of this whole thing is to make sure that when whatever angle we want it at, it stays there. So it runs the PID loop by taking the sensor data, and basically just it's a closed loop algorithm, and this is the receiver we are using. Now I'll show you the wiring in a bit, but yeah, basically this flight controller is like one of the cheapest flight controllers you can build by yourself. But this full disclosure, this does not work very well. I mean, it works pretty well, as you can see in the video I just showed in the beginning, but this flight controller has a lot of issues. Like this gyroscope, I have this mounted here on a like the female connector thing. So this is all soldered on a perf board, but you need to do that. Like if you use a breadboard, the loose connections will absolutely screw up the flight controller. It just ends up disconnecting all over the place and just randomly falls out of the sky. All of these are also on jumper pins only. Wait, I'll just show you. So basically this is the basically under this I have manually soldered all of these cables. I'll remove the flight controller and show you in a bit. But basically the way this works is I have ESC connected here. So you need the common ground connected to the Nano. You need signal pins connected to the Nano signal pins. And then I have 6 pins for the receiver, 6 channels. So the channels which we are using are basically all the 4 channels for control. So roll, pitch, throttle, yaw, and then 5th one is for arm and disarm. So it's a physical arm switch. So in this case I have this one as a physical arm and throttle cut switch, and then I have this switch which is connected to channel 6, which selects the mode. So there are 3 modes on this drone: angle, horizon, and acro. So obviously we need the 3-way switch for this. Now I am using an i6 here instead of the CT6B I normally use, because this is just a bit easier to use. I'm not using S-bus, I'm using standard PWM outputs from the receiver, and all of these buttons which are there on the switches which are there on the i6, you can manually configure them on digital radio using the CT6B as well. So if you want to use, but if you are using the i6, I'll just show you the way I'm using this. So if you go into here, right, and you can go down here into aux channels. So what you have to do is basically just set up channel 5 as switch A, which is this one for arm and disarm. I have channel 6 for switch C. So for the 3 different modes, I have 3 of these, right? And then if you go down here, first of all, I need a bit of you can change the subtrims so that it's exactly 1500. I'll tell you more about that in just a second. But yeah, if you go down here, one very important thing is so basically the way I have this setup is this switch enables like a trainer mode sort of. So when it's up, it limits the channels to 50%. As you can see here, the normal channel 1 is 50%, and when I put it in sport, like I flick the switch down, it goes to 100%. That's what you should set up channel 1 and 2. Don't mind with the yaw, because the yaw is not that sensitive anyway, and it is fine if it doesn't have a sport mode separately. Other than that, basically you can skip all of these. Don't need any of these. What you do need to do is here you can have fly mode to be switch B, and you need throttle hold to be switch A. Idle mode is nothing, we're not using that really. And then yeah, throttle hold, when you go here, you want it to be on and you want it to be at 0%. So on the CT6B, it's basically, if you use digital radio, you use basically set a variable, one of these variables to channel 5 and one of these to channel 6, and then you use a cut, like you just enable, you use both the switches there, and you set the switch to that like mix basically. So when you flick the switch on, then the mix goes, otherwise it'll just go to 0. So that's the way you do switches on CT6Bs. And also you just set the throttle cut to the channel 5 as well. So when you cut the throttle, it'll cut the throttle and it'll change the like the variable ka input. So then basically it's the same thing. This is just more convenient to use, so that's why I'm using the i6 here. Yeah, anyways, so the wiring. So first of all, I'll show you the power systems, and then I'll show you the wiring of this in a bit. Like it's a once I'll just show you that when I open it up. But basically the way this works is I'm using the F450 frame here, as you can see, obviously. And so down here you'll have, whenever you buy an F450, it comes with a PDB or a power distribution board. Now the way that works is basically, one second, I'll just move this here. I'll just move the controller away. The way this works is basically you put power inputs here. As you can see, I'll move these ESC pins and stuff out of the way. I'll just disconnect the receiver as well. Just a second. Yeah, anyway, so you basically just move. Yeah, so basically you have power inputs here. So as you can see, I have my XT60 here. The power inputs goes here, and then basically you have ground and plus pin, like basically positive and negative pins on all 4 corners of it. As you can see there, that's the two corners which lead to the ESCs. So the way that works is you basically just solder the ESC directly on. I don't know if I can show it. Yeah, you can solder the ESCs directly onto the pad like that, all 4 ESCs, and that just gives power to everything. Now the thing is, the F450 ka PDB is kind of shit. Almost every F450 PDB has this issue where your ground will get blown away, so, or blown off, whatever. So basically, as you can see here, my ground was also gone. So I have a manually jumped all the grounds. So as you can see here, I'm going from this ground to this ground, and then there's one wire going from here, from down to there to the other ground, and there's one looping from there to the other ground. And basically it's all 4 grounds are manually connected via a wire. You also have to use thick ass wires, otherwise it will literally melt. And then if you see here, I have 2 thin wires coming off of that as well. So these 2 thin wires basically go to this buck. Now this is the nicer buck, the one with the USB port, because it is obviously very sensitive. I mean, if you have some kind of an error with the buck where it throws nonsense signals and the receiver, or sorry, the Arduino resets mid-flight, then you are obviously in trouble, because you don't want a drone this big falling out of the sky. So because of that, we are using a really nice buck here, and that buck basically goes and powers the receiver directly, and it has the output signals which goes into the microcontroller ka input. I'll show you that wiring in a bit. So this is the receiver, the power input, 5-volt input for the microcontroller. Yeah, so that's it for the physical wiring. Now I'll open this and I'll just show you the wiring under the microcontroller in just a second. Okay, so as you can see here, I have the microcontroller and the basically the flight controller out. Right, so first of all, the things we want to talk about are the gyroscope. So basically, as you can see here, the gyroscope I have is the 6050, as I said before. But if you notice, the actual socket for the gyroscope is much larger than the number of pins there are. That's because I wanted to upgrade to this. So this is a 9250, as I said. Now this one has 11 pins, so this fits in perfectly like that, as you can see. But the thing is about this is basically this requires a much faster I2C speed or use SPI, with neither of which the Nano is capable of like reliably. So because of that, I decided, even though I have the connector, I just rather put this on for a much more stable flight than the 9250, even though this is a much better sensor as is, and also this has an onboard compass as well. But still I decided to go with the 6050. So if you are building a Nano, do not buy the 9250, just instead use a 6050 only, because it's much more reliable. Okay, so other than that, basically what we have to talk about is just the wiring, right? So first of all, these are our ESC pins and these are our receiver pins. So as you can see, there are 6 receiver pins and 4 ESC pins for the 4 motors and the 6 channels. So the way these are wired, and oh right, these are the power input pins. So the way this is wired is, okay, if I flip around, you'll see that there's a bunch of wires, but don't worry, this might look a bit complicated, but it's actually pretty simple. So we'll start with here. So these are the pins for the magnetometer, sorry, the gyroscope. And so basically, as you can see here, we are only using 4. So power and ground, and then there is the 2 SPI, sorry, I2C pins, so SCL and SDA. So SLSD obviously goes to A5 and A4 of the Nano. I'll have the full wiring diagram in the description as well. But yeah, just to explain, so these four will be used. So whatever size thing you have, you're only going to use four. So it doesn't really matter if you have a lot of pins or just four pins. As long as those four pins are connected properly, the whole thing will work. And then, so the way the powering is wired is basically the main input, the 5 volt input from the buck goes straight to the VIN of the microcontroller, and the ground goes to the ground. So that powers the microcontroller. And then the Arduino basically powers through its own 5 volt pins. So if you see here, we have a 5 volt here on ground. So that is what is connected to the 5 volt and ground of the gyroscope. So that's the way the wiring is done. Now, if you might have used receivers and ESCs and stuff before, you would know that you need a common ground to the microcontroller for both the receiver and the ESC. So the way that is done is basically the ESC's ground pins are all four of them are soldered together here, as you can see on this wire, which is then jumping to the ground of this. And the way the receiver is getting the common ground is simple. See, the wire which goes from here to the buck, if you would have noticed, there's another wire going from that exact socket. So those two are coupled together. So there the ground is being mixed, and the other set goes to the receiver. So the ground is looped at the buck end of it, not on this side. So that's why there's only the signal pins for the receiver, but there are the ground and the signal pins for the ESCs. So yeah, the actual wiring for this is all digital pins. So we'll use every single pin from D2 till D11. So D2 will be so D2 is an ESC pin, and then D3 D2 is the throttle pin, yeah, and then D3 is ESC, and then D4 till D8 I think are the rest of the pins, and then D9, D10 and D11 are again ESC pins. Again, the wiring diagram is down in the description, so you don't have to worry about me speaking it out. So yeah, basically we have all the digital pins used. In the code, which I'll talk about in a bit, you can use 12 and 13 for additional 2 channels as well. The software has the provision for that, but obviously most receivers, including mine, is 6 channels, so we don't have the 2 other channels, and not really needed as well, in my opinion, for a drone which is not doing much. In like, our drone isn't doing like, it's not actually delivering payloads or anything. Anyway, so that's it for the microcontroller itself. Now, one thing I wanted to talk about is again with this itself. So as I said before, this is a good microcontroller for starting. Like, it flies pretty stable and it's pretty decent, but if you do want to fly a proper, like a speed bee or something, so for that you need one of these. So this is an STM32. This is a black pill. So this is a F411 CEU6 black pill from the VApp Studios. Right now, this one, the thing is, so I have been working on this. So my idea was to use a stack, something like this. So over here we have a LED, an OLED gyroscope, compass, barometer. This is just a 3.3 volt regulator for this, and then there's a time of flight sensor as well. So the point is, this one has a much faster I2C loop, and this is much more powerful. So in the future, if you want to load, say, Betaflight or something, we can do that. Now, I have been having many issues with this, which is why this is not done yet. So if any of you guys can help me with like, basically the issue I have is this board goes into DFU mode. I can program it, I can successfully load Betaflight on it, but the thing is, as soon as I disconnect the board and reconnect it without it being in bootloader mode, it doesn't even show up on the computer. Like, it just doesn't register as a board unless it's in DFU mode. So unless I hold boot and then plug it in. So if anyone could explain why that is happening and how to solve that issue, that would be great. So this is the work in progress. This will handle in the future. Yeah, the MPU 9250, which I was mentioning, this is what we'll use for the 9250 in the future as well. I have a backup, like, basically this is a backup gyroscope which I am running now in case I am able to run this array on a Nano. But then so basically I soldered it on to run it on the Nano. I thought maybe if I try it with the Nano first, and then we can work on that later. But here's the thing, there's well, now when you're using these many components, there are 3, and then, well, even 4th one. So there are 4 I2C 5, because the OLED as well. So there are 5 I2C devices if I'm using a TOF, and even if I'm not, there's still 4 I2C devices. And basically the I2C of the Nano can handle this, but as soon as you load the libraries, there's not enough RAM on a Nano or a Uno to just handle that much I2C. So the only way to run this was on a Mega, and obviously I'm not going to fly the drone with a Mega on it. So right now this is not being used. I will have to eventually figure out what to do with this guy and then do it. And ideally I would love to write my own code because Betaflight, if you know, wouldn't handle OLED or a barometer. So either I'll have to use Autopilot or write my own flight controller code. So if anyone has any ideas about that as well, would be great help. So yeah, I'll go ahead and show you guys the code now, and like basically the way we program it as well. Okay, so basically in the code, now as you can see in the description, you'll find a folder like this. Now in this, first of all, you want to go here and you want to open up this thing. So the Arduino file. Now in this file, when you open it up, you'll see multiple subfiles. Now once it loads up, I'll just show you. So as you can see here, it has many files in this. Now you don't want to touch any of these really. One second. All you want to do is scroll to the end, go to config.h. Now this is the only file you care about. So the thing is, it's already set up as it is for the MP6050, but I'll just explain some stuff to you. So first of all, this is where we define the type of flying thing we have. So it can be a quadcopter, so quadx, or it could be like a dual copter, single copter, whatever airplane. Basically the type of flying thing you have, right? And then you don't have to worry about any of these. You want, if you are using some other gyroscope like the MPU 90 to 50, as I mentioned before, needs a faster I2C speed, so you have to use this one. But in general, I found that it is very unreliable with the Nano, so just keep it at 10,000 or 1 lakh or whatever, 100 kilohertz basically, and just use a 6050 only, or like yeah, basically just use the standard stuff. Don't use the 90 to 50 and stuff like that, because it starts giving errors, random errors, which can cause like mid-flight failures, which we obviously don't want. Now these are the IMU boards. These are the ones that are recommended for this. So G521 is R1, the MPU 6050. There are other boards as well, like these ones with integrated compasses and barometers and stuff. I mean, most of these boards are for flights. Like obviously, there's no other reason to have a gyroscope, a compass, and a barometer in a board. So yeah, these are the IMUs that you can use. All of these, and these are independent sensors. Like let's say you have a 6050 and you separately put a compass or a accelerometer like this one, or you can put a barometer and stuff like that separately, and you can use all of those. It's not a problem. It's just that again, Arduino Nano doesn't have that much capabilities. So if you start adding sensors on it, it will end up lagging out, and at some point it might even stop. Like it can crash mid-flight, which will be a bigger issue. So I just recommend, if you are making thing with that many sensors, as I said before, just use an STM32 based system. So yeah, don't try and put too many sensors on the Nano, because it is very unreliable. Yeah, that's basically it, majorly for everything. I mean, one thing down here which I do want to show is this. So this is the aux 2 pin, right? It's on 8, as I mentioned before, but you can put it on aux pin 12. So the aux pin 8 is shared with the buzzer, and aux pin 12 is a power pin, like power input to measure the battery voltage. Again, it disables either one, whichever one you use here. So I disabled aux pin 8. I mean, I'm not using aux pin 12 either, but it just made more sense for me to have everything in the row. So that's why I put it in pin 8. Yeah, that's basically it for the code. I mean, you just upload this, and that's basically it. I mean, there are other stuff you can go through it. It's pretty it's pretty self-explanatory, honestly, if you want to go through any of these like landing lights and shit. Yeah, GPS don't, again, Nano will never be able to handle that much stuff. If you are trying to use all this and you do want to use the are like not use the STM, I would recommend flying it on a Mega. That I have, even I tried to do that, and it worked much better than a Nano, but obviously it's much larger and harder to package. But yeah, if you want to use all of these features, then it's much better if you use a Arduino Mega instead of a Nano. Yeah, that's basically it. I mean, just upload this, and then the biggest thing is, over here, if you go to multi config, you can find the configurator file. This is the configurator app type thing for this. So basically, you select your port here, and then you will connect it, and then click start. Wait, I'll just show you 1 second. Right, so as you can see, I just plugged in my Nano here. So as you can see, when you do this, you can select the COM port. So I just hit on COM 14 and then hit start. So when you do that, you can see the actual gyroscope readings here. So as you can see, I'm moving the board, and it does take that reading in like that. So that's the actual gyroscope reading out. You can see the accelerometer values here. So you just hit calibrate accelerometer, and it will calibrate it. These two should go to 0, and the Z will be around 512, which is exactly what you want it to be. Right, I don't have the thing connected, as obviously I removed the like the flight controller. But here's what you want to do. You want to have arm low on aux 1, and you want to have angle mode be low on aux 2 and horizon mode be medium on aux 2, because the three things, right, as I mentioned, the triple switch. So basically high is by default going to be acro mode, because like basically if when the thing is high, that's when it go like it basically if it is not in angle or horizon mode, which is when the thing is high, it by default goes to acro mode. So yeah, that's the way this works. And arm should be low, so when the switch is up, that's arm, so you can easily click it down if there's some kind of an issue, right? You can ignore mag and beeper for now. I mean, yeah, most of this stuff is pretty self-explanatory as well. Oh, one nice feature about this is when you do arm it, right, then you can see these values actually move. Like if you have this connected to your drone and have it connected to your computer as well, you can actually see the values move here. And like as you move it, you'll be able to see the motors correcting according to which orientation it is in, right? So that is something I find really cool about this, and that actually helps a lot in troubleshooting. Like for example, if you have like these views, right, if you have some kind of a error in your orientation, that's a big problem. Also these just representation of having clockwise and counterclockwise motors, right, along with the this thing, the actual wiring, like which pin goes to where. So that's digital pin 3, 10, 11, and 9. That's where those motors are. So yeah, that's basically it for the code, really. I mean, it's a pretty simple process to upload the code, and obviously I didn't write the code myself. This is a multi-v. This is something you can just download and upload on your own. But yeah, any help with the STM based thing would be very much appreciated. So please leave any suggestions down in the comments. And yeah, I hope if you have any other questions as well, you can ask them in the comments. Yeah, I hope you guys enjoyed this video, and yeah, I'll see you in the next one.